there are two major functions are involved here. One is resize, another one is reshape. So for the first thing, we are going to use np.arange, okay, of 24. We know what a range is for, is to provide you a range of values, and we can store it in a specific array variable. So np underscore array. Now, if I print this np array, you can see that it's completely a flattened array. Okay, it's not in the dimension of, it's not in specific dimension. We generate a flattened array of elements. So now we want to reshape this. So how do we reshape this? In the last session, we observed that when matrices of data are provided, we can flatten them by using a flatten function. But right now, I'm providing a flattened element, and we want to reshape them or resize them. So to perform the reshape of this particular array elements, or the ND array elements, we have to use the function called reshape. So let's go ahead and use this array variable, np array, and the function that we are going to use here right now is reshape. The first function that I'm going to define you is reshape function. The reshape function will take a couple of parameters. So reshape of, let's say I have 2, 6, 2 is a reshaping size that I've provided as an input for this reshape method. Now we'll capture this in another copy of an array variable. Okay. Please be noted that we are using the reshape method to produce the new shape of this particular flattened element. So now we can print this as well. np underscore copy. Okay. So when I execute, you can see that it is completely reshaped. The flattened element is completely reshaped, and the reshaped element is captured here in this np copy variable. So we have this variable here. This variable holds the new shape of this flattened array. Okay. So right now we have two array elements. One is np array, another one is np copy. Okay. This one is actually having your flattened elements. That is this particular array of elements are stored here, whereas an np copy is having a reshaped elements. So what is that happening here? 2, 6, 2. So let's say we'll try to change this as well. So 2, so it should be of more equivalent. If you multiply this, 2 into 6 into 2. Okay. So let's say 3 into 4. Okay, into 2. So if you multiply that, it should be coming to the number of elements as 24. Okay. So 4 3s are 12, 12 into 2, 24, right? So the resizing shape parameters should come with the equivalent of that total number of elements that's existing in the particular array. So you cannot provide a greater number of elements where you actually don't have those many number of elements in your array. Okay. So you need to be very careful. Now, if I say 3, 4, 2, what you can observe here is there are three slices are there. Okay. This is your slice 1, slice 2, and slice 3. In each slice, you have 4 into 2 4 into 2 matrices, like 4 rows and 2 columns. Okay. You can see that 0, 1, 2, 3, right? And you have 0 and 1. Indexing perspective, 0 slice, first slice, and second slice. So what you can observe here in the parameter is the 3 represents your number of slices, and 4 represents your number of rows in each slice, and 2 represents the column that you have in each slice. Okay. So np array dot reshape will have these inputs as in parameters 3, 4, and 2, or you can give it in a different aspect as well. So let's say 4 slice, and I need 3 rows and 2 columns in it, or 2 rows and 3 columns in it, any order. Okay. So, but if you count this, it should come to this number of values. So that is something which is very much noticeable. So I'm giving 4, 3, and 2. In that case, you have 4 slices: slice 1, slice 2, slice 3, and slice 4. And in each, you have 3 rows and 2 columns. Okay. So that's what we actually do with this reshape method. So reshape method is helping us in order to reshape your flattened element. That is what is happening. Okay. I guess that is a question. What type of an error does it throw when we save that in same NP array? No, practically it won't. See, if I'm giving it without a copy, okay, ARRY, and I'm not promoting it in a new variable. Okay, so I'm trying to capture it in the same. It's going to be the same output, no difference at all. Because what actually happens is initially this object was holding a flattened array, okay, of memory. So it was pointing to this memory. This NP array is just a symbolic name. Okay, it is just a symbolic name. So practically there are two memories are allotted: memory 1 and memory 2. In the memory 1, you have the flattened array. In the memory 2, you have your reshaped array. Okay. Initially, this NP array was pointing to this particular flattened array memory. Later, I redirected that NP array to point out to the new memory. Okay. So this does not make any big difference and you won't get any error. The reason I created a copy of it is because I don't want to disturb the source. I don't want to disturb the source memory and I want to point to that memory for a later reference. So in that case, we should not disturb this NP array because we might try to see the differences that happens between the NP array and a NP copy array. So that's the reason I created another variable. So if you notice, what actually happens in the functionality is the original array is not getting altered when you do a reshape. The important point to be noted here is, okay, the original array, the original source of an array, original source of an array, of an ND array is not altered by using the function called reshape. But if you use the resize method, okay, I'm talking about one more type of method called resize. Instead of reshape, we can even reuse resize. Let's see what's going to happen if I'm going to use a resize method. Please be noted, to be more aware of this, let's do this actually, NP array and NP copy array. Okay, let's try to print both the variables for our reference. So you can see, uh, okay, you can see that your source stays the same. So this is a NP array, NP array, and this is your copy, and this is your NP array. So your NP array is not disturbed. Your source is not disturbed. You're not altering your source. You're not changing the source. You're only bringing out a new memory where the matrices of data is projected, whereas the original source is not changed, right? Now the same thing we'll try to work out in resize method. So instead of reshape, I'm going to use resize. But this time what I'm going to do is I'm not going to use NP array. I'm sorry, NP copy array. Okay, this time I'm not going to use NP copy array, but I'm using resize method instead of reshape. Resize instead of reshape. So what happens here practically is when I'm using resize, let's comment out this. If you use a resize, what exactly happens is your original source is modified. Please be noted. This is also the NP array, which was initially in a flattened array appearance. So means this is a vector, right? It's a vector set of data, whereas now you have the matrix of data or tensors of data. It could be. So this NP array dot resize will inline the changes. Okay, the changes will happen inline to the object itself. Changes or the resizing will happen. Changes will happen in line to the same object itself. But that's not happening in reshape. Reshape will not change the elements of your existing object. This will not happen. Instead, it will produce a new object. A new object will be produced post it's altering the flattened array to a specified dimension of array sizes that's been offered in the parameter of the reshape method. Is this clear? So this is what the big difference that you will see between your reshape method and the resize method. So if you have any questions, please let me know. Is this clear to you all? So the number of parameters will all be the same. Reshape will also take the number of parameters, but how you want to reshape them. Okay, you can do that. So if in case we can even try it out this way. Okay, resize of 12,2. So when I do this, it's going to be of a 2D array. Okay, two-dimensional array. This we can do even. It's not necessary that you have to take it to the third dimension or tensor dimension. Okay, you have rows and columns. You have 12 rows and 2 columns. Okay, or you can have two rows and you can have even have 12 columns in that case. But multiplying it to it, you should reach out to this number of elements. So let's say I'm giving 6. Okay, now what happens is it is not giving us the right number of elements that we are trying to resize it. The remaining elements are marked as 0. Okay, by default, because it is capturing only till 0 to 23, can cater only till 0 to 23. The remaining will be of 0 elements. I'm sorry, the element value will be of 0. So we need to be little careful while we are working with the reshape and the resize. So be sure that you go with the right number of elements to be resized so that you get the desired output. So right now it's a 2D. Okay, so you can take it to the 3D or you can take it to the 4D. It's up to you how you want to take it forward. Great. Now, the next interesting feature in NumPy is we have a polynomial expressions. Polynomials, you know what polynomials means, right? So polynomials expressions can be applied via NumPy. Okay, so what is the functionality to be used in order to apply the polynomial expressions? The same np NumPy object dot, we have poly. Okay, so you can see there are many polynomial functionalities are available. Okay, divisions, poly divisions, poly subtractions, poly additions. Okay, derivatives, poly 1D. Okay, I'm going to use poly 1D right now. You can explore more about these functions later, but I'm trying to give you a gist of this in this method, what this method actually does. Okay, np.poly 1D. Okay, and you can forward your values like this. It's going to be of a linear expressions. Okay, polynomial expressions in a linear expressions. We are going to provide the values like 2, 3, and 4. So I'm giving a list of values, an array of values to this polynomial 1D, and I'm going to capture it in a variable. Okay, so once you get this, you can try to print this and see what's actually there in the P. Okay, this is what you have. So what it produces is x squared plus x plus some value. Okay, let's assume like this. So what happens here is it's taking the coefficient values like 2x squared. Okay, this is squared, please be noted, it's squared. 2x squared plus x, that is 3x plus 4. Okay, 2x squared, 3x plus 4. It's been converted to such expression. So what type is this PS? So let's explore that as well. What type is this PS? This type, the P is nothing but polynomial 1D type. Okay, polynomial 1D is a dimension, one dimension type. And we can inject the value to the x, the unknown. Okay, so this is what is the unknown variable that we have. So 2x squared plus 3x plus 4. So what is this? X is not known, so I'm going to provide a value for it. So let's say x equals 2. So when I provide x equals 2, then you can derive this expression. Okay, and you see what is the final output. So to do that, we need to say the polynomial 1D object, the P of what you want to express here is, let's say, 2. So when I say true, you get the output as 18. So that's nothing but 2x squared. So 2 into 4, okay, plus 3x, 3 into 2 plus 4. Okay, so in this derivations, okay, while we are performing this derivations, we are trying to produce the output as uh, x values. The given input value is 2. Same way you can keep altering the values as well as and when needed. So let's say 3. So accordingly the value will change. Okay, it is more similar like mathematical expressions, right? So what we achieve with NumPy is what we are trying to do in a mathematical expressions can be achieved with the help of NumPy functionalities. The NumPy functionalities are helping us in providing more of mathematical functionalities and statistical functionalities as well. It's not just about the mathematical functionalities, it is also with statistical functionalities. There are lots of functions are there. But to be more of advanced functionalities is where we go for SciPy. We use SciPy for more of such functionalities. But here it is only of limited functions. But we majorly deal with array of elements, and that too the array of elements are on different dimensions. The dimensions are very important here. It is dealing with different dimensions like 1D, 2D or 3D more efficiently and more effectively. Okay, so that's the major highlight of NumPy. But also it offers a complex mathematical functionalities and statistical functionalities as and when required. So the one last function I would like to explain right now is uh, the line spacing. Okay, I have a function called np.lin space. This is linear algebra. When I use lin alg, it is for linear algebra. Okay, linear spacing. We want to give a equal spacing, linear spacing. Okay, and I'm going to say the 0 comma 25. Okay, comma 5. So this is a number of parameters that we are providing to it, and we can take the output of that functions and we can print this as well, p. So if you notice, you get this value. So how many number of elements that you can observe here is 1, 2, 3, 4 and 5. Okay, so there are 5 elements. So this says how many number of elements you need. How many number of elements you need. How many number of elements. This will be your spacing values. Okay, you have to space out with 5 elements. 0 to 25 is the range, and you need to space out with 5 elements equally. It has to be splitted. So starting from 0, and then you go till 25, right? These are of floating. You can see that it's of more of floating expressions. By default, the linear spacing, equally spaced out, linear spacing will provide a floating type of values. If you want to bring them out in an integer, by now you knew the answer. We are supposed to use the d type and use the d type as np.int. Okay. So by this way, now what happens? It's getting equally spaced out using integer representations. This might not be equally appearing because we are not taking it in terms of decimal expressions, right? So, but it's equally. It looks like equally splitted into 5 number of elements. The enforcement here is I'm using it as an integer. That is very much important. But default type is float. Default type is float. But right now we give it as an integer. Okay, this is for linear spacing. This is what we frequently use when we want to plot a graph. Okay, if we want to plot a graph based on set of data, plot a graph. I will be showing a demo today on this as well. We'll be seeing how to bring out a graph using some linear spacing and sine functions or cos functions. So we can bring out a graph based on this equal spacing of x values and y values. You can get the linear spacing of x values, and then you can provide the x value to the sine function, and that might produce an y value, and you can plot out a graph by using x and y. Okay, so I'm just trying to give you the application of these linear spacing functions. Okay, one example is you can use this effectively when you're trying to plot out a graph for x values or y values or whatever. You can give, let's say I'm giving it to be 6. Okay, you get equally split it into 6. So this says the number of elements, and this becomes your number of range. You can even start from 1. Okay, and if it's not of a d type of integer, then it's going to be in the form of floating expressions or floating values to say. Is this the only type of spacings we have? No, we do have geospacing. Okay, we do have geospacing, and that means it's a geometric space. Okay, then we have log spacing. Okay, log spacing, right? So this is also feasible. So when I'm saying geospacing of 1 comma 25 comma 6, so you can see geometric spacing is also produced for, I'm sorry, okay, now you can see that 1 2 3 4 5 and 6. Okay, the same way you can do it for log space as well. This might be used for different use cases. Now if you look at the log spacing will be having a different exponential values. You can see the exponential values are coming up because these are log values, right? In the log value, you are equally spacing out into 6 elements. Please be noted. Okay, so the internal, these are readily available functions: geometric spacing, log spacing, linear spacings. These are most of the functions. What you experience here is all mathematical functions. We might not be sure about what is the major use of geometric space, but once you get into some real-time use cases, you might get to know that, okay, we can use such kind of a functions here. Okay, you will get to know that only when you drive through the real-time applications. So we have to figure out a way to find out the problem statements in such a way that it maps to the real-time scenarios as well. We have to work out a little hard over there. Okay, so right now I'm trying to demonstrate with linear space in terms of plotting the graph, but I'm also giving you a clue that it's not only based on a linear spacing. You also have a geometric spacing, and you're also having a log spacing. Okay, great. So we learned a lot of functions today, right? Resize and reshape, and the difference between resize and reshape, right? And then we got the understanding of polynomial expressions to be expressed via NumPy by using poly 1D. And then we also saw the linear spacing, geometric spacing, and log spacing. So what else? What other functions we have? We have to see that. So let's see that now one by one. And interesting functions. Another 10 minutes of time, probably 10 to 12 minutes of time, we will see few more functionalities that are used in NumPy object. Okay, np dot zeros. You have a function called np dot zeros, and you have a function called np dot ones. Okay, so I can print them directly. I'm not going to capture it in any variable. This is only to get some understanding of what the functions are going to do as. Okay, so when I have zeros and ones, it takes in a parameter. So for let's say, for example, uh, if it's a zeros, okay, you can see the shape is missing as in parameter. So what you need to provide here is the shape. Okay, the shape, two elements. It's actually a scalar element. I'm sorry, the vector element we have in the vector here. Okay, two elements are there. Both elements are 0 point, means zeros will take a floating value as a default value. One dot is for ones. Np dot zeros taking two elements, uh, two as a parameter to produce two number of elements of zeros and two number of elements of ones. But actually we need to set the different shape by saying a tuple of values. You can have a tuple of values 2 comma 3, uh, 2 comma 3. The closing braces is a problem. So you can see 2 rows and 3 columns all filled with zeros. So what zeros will do? Fill all the elements with 0 and produce a matrix shape. Okay. Uh, and similarly, you have ones. Fill all the elements in the shapes, in the different shapes with ones. Okay, 2 comma 3. Sorry, tuple should be of a tuple of values. Okay, so fill with all ones. Plus you can go for a next shape also. So what would be this shape here? You have before it was vector, now it is matrix. Okay, I'm taking it to 4. So you practically see slices two slices, and each slice is carrying 3 rows and 4 columns. 3 rows and 4 columns. 3 rows and 4 columns. Okay, there are 2 slices in here, right? Each, that is zeros, there are 2 slices, and ones, there are 2 slices. All are of float. So you can go ahead and say that you can change the type, the D type, to be of an integer. Np dot int. Okay, the same way here, D type np dot int, right? Everything is of integer representation. Before it was with decimal points, but now it's not in decimal, so it is in real numbers. So we have 0 and 1. The one more thing that I can do here is, after having this zeros, I can say plus 3. This plus 3, what it does is, it will produce zeros, but all the elements will be added with 3. So you can see sometimes you need all the elements to be appearing with some certain number of values. So I can say 3, 3 plus 0. Okay. Wherein here in once, if you say the same 3, 3 plus 1, it becomes 4. Okay. Do we have twos for that? Do we have a twos function? Do we have a threes function? No. We have only zeros and ones function to produce a matrix representation or vector representation or tensor representation. But we don't have functions like twos or threes or so. We have zeros and ones, and from there you can manipulate to a respective value by just adding them. Okay. The 3, or you want to do some multiplications, you do it. But generally, zeros and ones are used for testing purpose. Okay, we'll be using this effectively in some testing purpose of some expressions, so you can effectively use these two functions, right? So if you have any questions on this, please let me know. See, you want to give an expression here. You can see if I'm multiplying it with 3. Okay, 3 into 0, it becomes 0, and 3 into 1, it becomes 3. But you want an expression to be like this: 3 into 2, so that you get 6 plus 1, 7. Okay, that is a common uh, mathematical expressions which you can define, okay, by using some braces. So it'll multiply 3 into 2, 6, and then you add them with this value. Okay, 6 plus, these are ones, right? So 6 plus 1, that is also feasible. Those are only mathematical expressions, so you can go ahead confidently and give such expressions as well. Yeah, any other question? Okay, great. So the next thing that we have to learn here is a custom data type. How to create a custom data type. Custom data type. This is a very important topic. Okay, custom data type, creating a custom data type. So far, if you have noticed here, we are using predefined data types like int, right? Now I want to define a custom data type. So to define a custom data type, you can use the dtype function. Okay, dtype function to generate a custom data type. But before we go into the uh, creation of that custom data type, we will try to see the record array. Okay, I'll bring back to the custom data type because it will be more meaningful if we use some use case for the custom data type. But before that, we will see record array. Okay, record array. Array will be recorded with some specific field names. Record array using field names. Field names. What does it mean? Record array using field names. Let's go ahead and quickly create an array by using np.array of. I'm going to create a 2-dimension, right? And here you can use a tuple of values 1.0 comma 2, 3.0 comma 4, 4.0 comma 7 something, and you have another set of elements, and here I'm going to say 5.0 comma 8. Please be noted, I'm giving a floating value and an integer value, right? Then 7.0 comma 9, and then coming back to 6.0 comma 3. So you have a combination of this array, and we are going to store them in ARR. Okay, so we have this array element, and if I'm printing this, you get the output like this. Okay, so these are tuples. Actually, these are tuple values. Okay, collection of tuple values. So that's why it is taken as a individual list of elements, right? Now, when I'm having this, I need to define a type for it. So to define a type, we need to use d type here. What type of values that we are enforcing there, we need to provide that by using d type. In d type, we have different variation of data type representation can be provided. Please be noted. So far, we were using int or float, int 16, int 32, or int float 16 of float 8. Right now, I'm going to use the d type. That is, I'm representing the tuples values type 1.0, 1.0 x comma float 8. Okay, this is one type. The next type 2, 4, 7, 8, 9, 3 is all going to be of integer, and I'm going to represent that integer in a field called y comma i8. Okay, please be noted. This combination of, this is your data type. This becomes your data type, and this becomes your field name. Field name. Field names are nothing but column names. Okay, you have rows and columns, right? You need to define a column names, right? That's what I'm doing here. Even here, we can represent more similar like a relational database column names. So here I'm referring the field name for this particular set of values. Okay, 3.0, 4.0, 5.0, 7.0, 6.0 is all of float values. Float and carrying the x as the field names, wherein 3, 7, 4, 8 is all representing integer and carrying the y field names. You're getting it? So that's what we are doing it here using the d type. See how we are uh, enhancing the usage of d type. It might seems to be complex, but if you closely look at that, it seems to be pretty easier. We are giving a field name for all these consecutive values. The first column, this is your first column. Okay, for the first column, the field name is x. The second column, the field name is y, and the column's data type f8 and i8. That's what I'm doing. We usually do this in SQL, right? Structured query language. You will create a columns and you will represent the column names as well. Column names and then column data types as well. The same thing is what I'm doing here. Now, if you look at this, the output will be more reasonable because it's a 2D. Before it was not like a 2D because we didn't represent the data type for a perfect shape. Now you can see it's a 2D array. I'm sorry, yeah, 2D array of rows and columns representations. Okay, so the first one is all floats, which is of x, but you're not seeing the x field names, but you will have the access to it. See how I'm going to access np array of x. Okay, so you will get all the x values. Are you getting it? See how easy it is to access through field names. I'm extracting all the x values. If you want the y value, okay, so let's say if this appearance is possible. No, it is not. So we have to go for y. So you get the y value, extracting the y value. The particular column values alone, you're fetching it through this field names. Okay. Now, this seems to be little uh, critical to access. Okay. You use a array shape and then you use the field names. Okay. This I can use by saying 0. Okay. This way also you can access. If I say 1, means it's the first column. Okay. But you can see when I say 1, it goes to the uh, first row, 0 and 1. Okay, and captures those 5 point and 8, 7 point and 9, 6 point and 3. But you're not getting that exact column wise, right? So that's the reason I'm going for this easier accessibility by using X or by using the column of Y. But to be more precise, we can even have a little bit of easier way of accessing these fields. How? That's where we go in for this record array. Okay, we get into this record array. Now we have defined all the field names. Now we can use a record array to easily access those fields without having an array template of representation. This is an array template of representation. You use the square brackets, right? I don't want to use the square brackets. What I mean is, I just want to access the np array dot y, but I get an error. There is no attribute called y for this object. Okay, or I don't have an attribute for x. I want to access in this way. It's more simplified version of accessing the elements via the field names by using a dot notation. But I don't have that option right now because we haven't turned out this array to be a record array. Only when it is in the record array structure, you will have the accessibility of such variables through this dot notation, or the field names through this dot notation. So what I'm going to do to come up with a record array implementation, I'm going to use the same np underscore arr, sorry, arr dot, you have a view function. So in the view function, okay, this is an array, nd array. Okay, in nd array, you have a view function. In the view, I want to view this object in an record array appearance. So np dot record array attribute, record array, RECARRAY. Okay, record array, and you capture it in another variable, or you can store it in the same ARR, as like we discussed in the initial uh, time, that you can store it in the same source itself. Now when you store it in the same source, it has to be stored in the same source in order to access these fields in case. So I'm saying dot x, now you get the x values. When I say y, you get the y value. But in the y, I want this specific position of value. Okay, so I'm going for 0th row. Okay, and first column. Okay, in that specific y field, you get the 4. Are you getting it? So from the field names, you can even go specific to the specific element value. So I want to access this 4 right now. So this is operated as what? Y value. In the y, I want to go to this row. So I'm saying 0th row and the first column, right? 0th row and the first column. So what happens? You get the exact value. 0, 1, 2, 0 and 1. You are trying to capture this 4, right? So by this way, it's easier for us to represent the value by using your field names. Why? You want the same in X. What do you have to do? Just change the field names. No array style of representations there. You get 3.0, which are float values. You're getting it. So this is what we call it as record array in NumPy. Record array in NumPy. Is this clear? So if you have any questions, please let me know. You have to look at this D type, how we have defined this D type. So the Function that we are using here is view function, record array, okay, directly accessed on top of the np object, view function on top of ndarray. Ndarray object carries a function called view function. View is helping you to turn out your existing array into a record array view. So when it is a record array view, it assembles your x and y. That is the meaning. But still you will be eligible to access through your array notations also. You can still use this array templating format and define your x. You still get the same output. Okay, that will not be changed. You will have a default access of those fields using the array representation. But added feature is you can use a dot notation and apply the x variable and you get the output. You're getting it. If you want more clarity on this, please let me know. So I don't want to move forward without giving you a better clarity of this concept, because the ultimate goal of these sessions is to have a better understanding of the concepts. So if you have any questions on this, please let me know. Okay. Hope I'm loud and clear as of now. Is there any challenge in the audio or video? Please let me know. Yeah, thanks. Okay. Now let's move forward to learn the two major use of this NumPy. Okay, we might be having more functions to be defined. Okay, the custom data type, as I was saying, okay, we do have a custom data type. We'll just quickly see that, and then we'll see the uses of these NumPy. So how do we define a custom data type? These are not custom data types. We are using a predefined data types, as you can see, F8 and I8. I represents integer, F represents float, and the 8-bit memory and 8-bit memories are assigned for float and integer here. But these are predefined data types, system defined data types, right? But I want to go for a custom defined data types. So to define a custom defined data types, I'm going to create a cust type equals np dot d type. You have a function called d type in order to generate a custom data type. np dot d type. Here I'm going to represent the field name as usual. You can give a field name, comma, np dot str. Okay, str or str underscore. You can use str. Str is Python's string representation. str1 is enhanced version of string class in NumPy. Okay, you can use either one. So I'm going for str underscore. Str underscore is proprietary to NumPy. Okay, NumPy. So let's take a class. I have a class called str. Okay, and this str is defined, right? I have a class called str underscore, okay, which extends your str, okay, which extends your str, and then it's defined. So str is defined, str underscore is inherited from str, but the str underscore will be used exclusively in NumPy. Okay, NumPy's proprietary string representation. There might be some memory advantages will be there in order to use this string. Okay, but you can also use str, no problem. So I'm defining the data type right now for this name field as np.str. Then I'm going to have another field names called a number of items, which is a field name, comma, I8. Okay. Then one more field name which is called as a price, and this is going to be of np dot float 32. Okay. So this is how a custom data type would look like. Now, what is the advantage of this custom data type? This style of combination of types will be reused in many places. How you will reuse it? Just with the name called cust type. That's all you have to do. You're getting it? So you need not create such kind of a combination of types n number of times. You don't need to write them n number of times. Reusability is the major advantage you come across when you're looking at this custom data type creations. Now, how we can use them? Okay, we have created the custom data type. Let's say print of cust of, I want to know the name, okay, or let's say price. So it will say fixed type of tuple, invalid shape and fixed type of tuple. Okay, somewhere we are going wrong. Yes, here there is no proper close. That's a problem. Okay, so now it will work. Now you can see float 32, prices float 32. And if you want to know the type of this number of items, it's a int 64. Okay, I guess this I8 is not considered for this type. Okay, this is not a bit actually. Here it is going to be of bytes. Sorry. Okay. So it's treated as a bytes. So it is a in 64. Okay, 64 bit. So 8, 8, 8, 8. 32, another 8, 8, 8, 8. 32, which is 64 bit. In 64 bit. So I8 is correct actually. I8 is byte. 8 bytes. Okay. 8 bit, 1 byte. Okay. So like which you have 8 bytes. So that's how the combination is. So we should not get confused. Sometimes when we look at it, it seems to be a little awkward. Here it says 8 and here it says 64. No, it's byte and here it's bit. Great. Then we have name. Let's see what name says. A Unicode string format, a specialized string format I'm using. Okay, if it's an str, also it's the same. Okay, str underscore is also the same because they both fall under the same category, right? So this is how you get to know the type of each fields by using the cust type. Now, what is this cust type itself? What this cust type itself is? So let's say type of cust type. What is this cust type is? Cust type is nothing but a D type. So what type of an object is it? Is D type object, a custom data type object, D type object. Now, how do we use them? That's the question. So to use them, I'm going to give you another array of values. So let's say items. I have an items. And I'm going to create an array of items, np array. And in this, we need to use three set of values. Okay. Now, it's a vector representation. Okay, it's not more than vector. It's not matrices or tensors. It's a vector value. Now this is the array of values that I'm going to integrate. The second one is I'm going to refer the D type. When I'm referring the D type, okay, D type equals, usually we used to say np.int, okay, or you'll be grouping them again here. You have to copy this. You have to copy this group and drop it here. But we don't need to do that. We don't need to write them again and again. Just you represent the type name. D type equals cust type. That's all. So what will be applied here? The rules what you have enforced here in this custom data type will be applied here. So you will have name, you will have number of items, and you will have price in each and every tuple. So I'm going to say the first one is the power of now, which is of a string, okay, comma. Then I'm going to have how many units of that particular book is 4 units, and then the cost of that book, floating value. The same way we can give the next element, think and grow rich, right, comma, I need 8 number of items, and the cost per item is this, the floating values. Then the last one is going to be 7 habits highly effective people, comma, number of items and values. So this is what you have in your array of elements, and that's going to follow this data type. Okay, now if I execute this, there is no error right now, so we'll just try to print them and see if we are getting the same output as desired. Okay, the one mistake we have done here is the reason why this string is not displayed, because for the string we haven't mentioned the size, how much number of characters to be stored. Okay, so that's a problem. Default is 0. Okay, 0 characters. So I'm going to say comma, let's say 60, execute it, and then execute. Before it was 0, you can see that I didn't observe that actually at that time. So 0 characters, but now that will be turned out to a 60 characters, comma, the third argument is going to be number of characters, 60. And now if I execute, you get the exact string values as well. Are you getting it? So now this follows the rule of this custom data type. It's pretty easy for us to reuse the custom data type. This is how you create a custom data type in NumPy. If you have any questions on this, please let me know. So you can play around with this NP just like that. Okay. Hands-on is something very important. You have to practice a lot. Only then we will catch up these concepts more in detail. Okay. So by doing a mistake, we learn a lot sometimes. So let's say, for example, if you don't give this, I didn't give this argument at all. Okay. I didn't throw out this argument. So, but we were in an assumption that u0 is by default considered, and it will allow the characters to be stored, but it is expecting the number of characters that the string data type can accept, number of characters. So now I'm saying the number of characters that can be stored is 60 characters, a Unicode characters. Any question? Now you tell me, we are ending up this with a heterogeneous type of NumPy array. Heterogeneous type of NumPy array. We started with, in the last class, I was trying to define that NumPy is a homogeneous. Yes, that's by default homogeneous, but we can turn them out to a heterogeneous also. The main advantage of NumPy is homogeneous, single type of elements. But here you can have multiple type of elements as well. And that's heterogeneous. If I'm not using this underscore, and if you execute this, it's still the same. The output is same. I'm executing, you can see, right? Nothing much of a big difference. Okay. It's all the same Unicode 60 characters, but probably the size might vary, or the performance might vary, or might have some other functionalities in that custom defined str underscore class. Okay, str is Python's own default string data type, but str underscore is NumPy proprietary string data type extended from the Python string only, to be noted. Please be noted about it. So this is how you create your custom data types. You can have any combinations. You can group it with any combinations to any complexity levels. Okay, and you can apply it while you're creating your n-dimensional array. While you're creating an nd array, you can start creating it with these custom data types applying into it. Any question? Okay, so I guess there are no further questions. Now let's move on to another use of this NumPy. I'm going to declare another import statement here. Import matplotlib. Okay, import matplotlib, and this matplotlib is actually helping you to create a plotted charts. You can create plotted charts with this matplotlib, and this matplotlib is going to have a specific module called pyplot. Pyplot. Import matplotlib.pyplot as plt. Okay, I'm shortly referring it through an alias called plt. Matplotlib.pyplot as plt. Now this is a basic demonstration which I'm going to give you to have a first level understanding. Okay, let's create an x-axis of values. To create an x-axis of values, I'm going to bring that learning that we already had just now, np dot linear spacing. The linear spacing is going to be like this, -1, comma 1. Okay, linear space is -1, comma 1. And if you try to print this x, okay, you can see that it's stating its default split up of this by having -1 to 1. So let's say if you just want 10 number of elements, you can give that number. Otherwise, it will have its equal ratio of splitting. Okay, -1 point, 0.95, 0.91, 0.87. So it has its own default uh, splitting of elements. If you want to give your own splitting, you go ahead. But for this plotting of charts, I want to give it without the, if you look at it here, start, stop, see the parameter arguments, variables. Okay, if you look at here, so we have start, stop, a default number of 50 is taken. Okay, but you can define how much number that you wanted. You have endpoint to be true, by default is true. Okay, I'm going to say, let's say endpoint to be false. So when I say endpoint to be false, you will notice that this will be excluded. The endpoint of this value 1 is excluded. It will stop till 0.96. After equal spacing is nothing but 1. That 1 will be excluded. You don't want that endpoint. But if you want the endpoint, you leave it without an endpoint reference. So default is true. So it will include 1 also. When it includes 1, you can see the difference in the spacing. Okay. So that's what it is. Let's say 10. So you get the 10 numbers, but 1 is included. but when I say false, the endpoint is excluded. It's completely excluding it. Okay. So now in this case, this is a basic understanding of this linear spacing. Let's go for 1 minus 1 comma 1. That's your x values. Okay. Then I want to generate the y value as well. So y value will be generated by using np dot sign function. Okay. Sign function of, you need to drop in the x values. The x values have to be dropped in. Now you can print the x and see what's the output is. So you can see the sign values of these minus 1 dot sign value. Okay. I'm sorry, y value. Okay. Minus 1 of the sign of minus 1, sign of uh, minus 0.95, sign of minus 0.91 is this value. So whatever you are seeing here is all the values of sign functions, the values which is generated by using a sign function. These are generated with the help of your line spacing, linear spacing, or we call it as linear spacing function. Okay, linear spacing function and sign functions. So when we are having this x values, we denote this with x values, and these are y values. Now we got the x-axis values and y-axis values, which can be clubbed together to produce a chart. So how we are going to produce a chart here? That's the reason we went in for importing the matplotlib. We will have more discussion about the matplotlib in the upcoming session. So if I come across with another training session in the next week, we will have more discussions about that as well. Now I'm going to frame a chart here by using the PLT. Okay, PLT dot, the first thing that I'm going to do is I'm going to create a title for the chart. The title is going to be, let's say, plot x and y. Okay, this is first setting. Then PLT dot, you can say plot. There's a function called plot. Now here where you need to take in the x and y. Okay, x and y values, you need to pass on this x and y values. Okay, and sorry, I didn't execute this. Okay, now you can see after plotting with x and y, you get this chart. Okay, you can see the values representing here. Okay, for the x and y values, you can also plot a label for it. If you want to define a label for it, you can use that as well. You can say plt dot x label of, you can say as x-axis, and plt dot y label function, and there you will be saying y-axis, right? And you can say plt dot show. You can even use the show function to show that. Can you see y-axis? These are y values and these are x values. So with that, you can easily conclude that these are x values and these are y values. Okay, and you get the actual a line, a curved line, which is of sine of x denotion, sine of x value generations. You get this curve, and the label is also there. The title, I'm sorry, this is your title for the graph. Now more interestingly, we can also have some arguments here, comma, that is x comma y comma. Okay, I can say o. When I say o, instead of line, you will see a dotted line. This is a dotted line, o. Okay, or I can say let's say, for example, a triangle. Okay, you can do this. These are shapes. These are shapes that we are denoting. I want an yellow color of this. So you get the yellow color. Y represents the color, and another one represents the shape. Let's say blue color. Okay, let's say green color. So you get different colors on that plotting. of the lines. Okay, you can use your own shapes, right? But it should be a more valid shapes. Okay, it all should be of valid shapes. So when I say dollar, it won't accept. You're getting it? So you have to use the appropriate shape to work around with that. So when I say asterisk, okay, asterisk, which will be represented in green color, but it is like a star, right? So you have this features also, but we have to study more in depth with matplotlib. We'll take it up as a separate learning later. But right now, what I'm trying to conclude here is we are integrating NumPy along with your matplotlib. That's what I'm trying to train you here. NumPy with matplotlib. And in matplotlib namespace, you have a specific module called pyplot. There are multiple libraries are there, Python libraries are there in order to generate your chart. Okay, so once this is done, you can also take this to be saved in some specific location. So I can say plt dot, you have save figure. Okay, and in the save figure you can use the uh, plot dot png. Okay, you want to save them in the png file, so this will be saved. Now how do we see them? So to see them, you can see here the plot.png is stored in the current directory from where the code is executed. This is the directory from where I'm executing this piece of snippet of code, and down there the png file got created. You can click this and it will open in a separate file as well. Okay, the chart is not getting stored properly. Anyways, this is how we save the chart into the specific file. So let's go ahead. Yeah, now it will be there. So see here, the chart got produced. So what happened was we showed the plot. After that, the plot is not used for further references. Okay, once you have shown, the PLT object is not going to be used for further references. So it's better you save the file and then you show the plot. So this is a separate PNG file which I've saved, and you can use it for further references. So for that, the function that we use there is save figure. Okay, is this clear? Yeah, of course it will be interesting, because as you go and keep learning on this, it is going to be more interesting. See, this can be integrated even with your Tableau. Okay, I'm not sure how many of them are aware of Tableau. Okay, Tableau is a business intelligence tool, analytic tool. Okay, business intelligence analytic tool, and there we will be integrating this Python features into it. Okay, you can integrate there. Instead of using matplotlib, you can use Tableau. Tableau will be more effective in generating more advanced charting features. Okay, these are programmatic appearances, but sometimes if you want to integrate it with some tool like this analytic tool, you can still go ahead and use them, and you can integrate this Python's NumPy features into the Tableau as well. If you have any questions, please let me know. This is very basic thing. We will not go much in depth into the matplotlib, but I'm trying to give you a understanding. Okay, it's just an understanding that how we can effectively use the matplotlib integrated with NumPy. Because at the end, we need to know that how the integration happens among the NumPy, pandas, the panel data, which I was trying to figure out last session. We will be having an exclusive session on pandas. Okay, next week I'm planning to come up with pandas. if time permits. Okay, I'll be coming up with another session on next week, so we'll be connecting up in order to learn pandas as well. Okay, if you have any questions, please let me know. We still have 8 more minutes. So one major understanding of this NumPy is what we are going to learn right now. So I might extend this to another 5 more minutes additionally. Okay, so please bear with me because this is very important. Okay, if I'm unable to complete the complete implementation, we'll carry forward in the next upcoming sessions. But right now, let's try to sum up with this final use case. Let me see how far that I can give you a better understanding of this NumPy using this use case. Step by step, we'll go ahead and do it. The first thing that you have to learn is I already have data in here. So far, we were giving only uh, uh, I mean data which is there available within the code itself. Okay, those are called as hard coded data. Hard coded data by generating with range functions. Okay, range functions, or creating it with array functions, or creating it with functions like zeros or ones. Okay, all these are hard coded values. But I have a real time data. How the NumPy can work on top of this real time data, that's what is very important, is right, because we will be having the real time data, and that real time data need to be pulled into these numerical Python tool and manipulated, and then make it more visually represented using the matplotlib. Okay, so we can keep integrating them sequentially. But if you look at this data which I have in here, student-data.txt, okay, if you look at this file, this is what is the data that is available. Okay, so what you can notice on this data is we have some subject ID. Okay, then we have student, these are student details. Let's assume that this is a student details. In student details, we have the subject ID, then we have the gender. Okay, male or female, then we have a date of birth, height, weight, the BP. Okay, so all these are the field names that we have, and the actual data are starting from here. And if you notice here, the line numbers are given. Please be noted, the line numbers are given. All these are uh, metadata. These are metadata, means an information about information, right? These are metadata. And you have the data till line number 9. Please be noted, from line number 1 to line number 9 we have only metadata, but the actual data is beginning from line number 10. From line number 10, the actual data is beginning. This is what we need to extract. These data is what we need to extract, and we need to do some manipulations. So how to do it is what we are going to see this right now. Step by step, we'll do it. The first thing is we need to load the file. Okay, we have the file, we need to load the file. So I'm going to give the file name. The file name is what? Student-data.txt. That's the file. Now I want to read the file. Before I read the file, let me create a custom data type. Okay, cust student t type. Okay, I'm giving my own name for this variable. You know by now how to create a custom data type. np.dtype of you can have an array of values in it, differentiated with tuple. There are two columns which I'm going to work around with. I'm sorry, three columns. So I need three type references. The first one, the field name is going to be gender. You're going to extract the gender. Okay, and you can have your type in there. Let's say np.str underscore comma 60 or 70, whatever it is. Okay, I'm giving the string length. The second is, okay, height, comma floating value. Okay, Then we have the third one, which is weight. I think right now we don't need weight. We'll try to take it up later because we don't have much time right now. So we'll take it up two columns. Okay, one is gender, another one is height. So what happens here is you have the actual source of data. Please note it down. In the file, you have the actual number of columns. Okay. Now I'm going to create an array, that is an ND array. And in the ND array, there is going to be only two columns. One is the gender, another one is height. So you need to extract that particular column data alone and store it in this ND array for further manipulations. This is the actual source. Okay, this is your destination is of what? It's an ND array type, and in the ND array, how many fields that you're going to carry is two fields, the gender and height, but the actual source has some 8 fields or 9 fields, doesn't matter about it, but you're going to extract the required field of values alone and store it in this ND array. Are you getting this? So for this, I'm creating a custom type to define the new array that we are going to create and capture those values. The next step that we have to do here is we have to use np dot, there is a method called load text, load text, txt function. There's a special function. This is a very noticeable point. np dot load text, and in this load text function, we need to provide the file name because this is the file which need to be loaded into an ND array. Okay, so file name, comma, okay, you can have the D type. You need to refer the D type for this ND array. What is the D type? What type of array that we are going to create now? We are going to create the custom student data type. Custom student data type. So we need to offer this type here. Okay. The next one is skip rows. There's a parameter variable name called skip rows. How many rows you want to skip? 9 rows you want to skip. That's why I told you to make a note of it. So what we saw here was there are 9 rows of data are just a metadata, which we don't need to carry that into my ND array. I don't need to carry them into my ND array, right? So we can skip them. To skip it, we need to use that parameter variable called skip rows, and how many number of rows you want to skip? The first 9 rows. And what are the columns that you need? You need the gender and you need the height. So where are those columns are existing? We need to see that. So those columns are existing in the columns are like 0, 1, 2, 3, 4, 5 and 6. So which column you want right now? The gender, column number 1, and the height, column number 3. So you need 2 columns to be extracted, 2 columns value to be extracted. So what I'm going to do right now is I'm going to use the column number 1 and column number 3. So how to use that column number 1 and column number 3? You have another parameter variable called use columns, and the use columns you need to provide a tuple value, and the tuple value is going to be 1, 3. It's not 1 to 3. Please be noted, this is not 1 to 3 columns. It's 1 and third column. 1 and third column. That's what we are using here. 1 and third. If you want the second column, then what do you have to do? You have to say 1, 2, 3. You're getting it? So the number of columns that you wanted, and that too the position of the columns. It will not include 0th column. So what are the parameters for this load text method? The file name, data type, skip rows, use columns. That's all. And this will be captured in one particular array. Let it call it as student array. Okay. And this student array need to be printed. Student array. See, it extracted all the gender details, male, female, okay, and their height. The respective person's height informations are captured. Now we can play around with this data. We can play around with this data, right? How to play around with this data? I want to find the maximum height of male candidate. I want to find the minimum height of female candidate. I want to find the average of the male height or the mean value of the female. So I can play around with this data right now. How do we play around? NumPy has that features as well. We'll see that right now. If you have any questions till this, please let me know. Before we go on, if you have any questions, please let me know. I'll not take more than 5 minutes. We have few more discussions. The remaining we'll discuss in the next sessions as we come across. If you have any questions till this explanations, that's almost 3 lines we have done. If you have any questions on this, please let me know. These are tuple values. So tuple values, you can see the argument that we are referring here. So it becomes an invalid syntax. 1:3 means it becomes 1 to 3, right? I don't want 1 to 3 here. It's 1,3. To ease up your job, probably you're saying to ease up your job, you want to use columns. Actually, you don't need to use columns in that case. Okay, you can fetch all the values or you define it with the tuple. Any other question? Okay, fine. So if this is clear, let's move ahead. Now I'm going to use something called conditional parameters. Okay. The first thing is I want to see the female datas. Okay, female datas. To see the female datas, I'm going to apply the condition np dot. There is a method called where. Where is used for applying condition. So how the condition is going to be student data or student array. I'm sorry, student array of. By now you know how to access the record array, right? So we need to fetch the record array by using, I didn't create a record array, but you can use the field names, right? You can access the field names, that is gender, using the field name. It will collect all the gender, it will collect all the values based on the gender called female, based on the gender, okay, based on the gender called female. So B is for the binary representation, okay, you can say F. So when you print this, you will see this array is going to carry the uh, uh, I'm sorry, gender equals female, correct? Student array gender equals. Why it is not fetching the data? Okay. Yeah. So I guess the problem is in the type. So there is a specialized type that we have here, a string representation. This notation is for extracting the single element. That one you can see here, right? That one is to extract only the single element of value. So that's why we use the special notation of pipe S1. S is in caps, please be noted. If you have two characters, you extract two characters. Why? Because while we are doing this equation of comparing the value, it won't compare with this single character. When you have that 60 or 20 characters to be stored in a string, okay, we will not have the choice to do the comparison with a single character. So it's better to have this standard of uh, type as well. Okay, this is going to carry a string with one character of extractions, so we can use that. And now you can see whichever is matched with female, those female indexes are produced. What this array will carry is, this array is going to carry the sequence of indexes. So you can see 2 is what, 0 1 2. Okay, 2, 4, 5, 8, 9, 13, 14, 16, 17 is all the positions where the females are located. Female values are located. So those female values, so 0, 1, 2, 3, 4. If you see here, second one, the second position or the second index, you have the female values. Fourth index, you have the female values. So those are traced. You are tracing the index position. So this where method will help you to trace out the index positions of all matched values, of all matched values. You're getting it? That's what this where method is all about. It's more like select gender from student where gender equals female, but actually it pulls out all the values, the gender values, but what you want is the index position. So where method will only extract the index position of those matched values. You're not seeing male indexed positions. Why? Because the condition doesn't match there. That's the reason, right? Okay, so now what we can do with this, we can do finding the female heights. So let's say, for example, female heights equals this student array of height. Next to this, you need to apply this female data, which is carrying all the index. So what this will do is, this will now find all the arrays, find all the values and store it in this female heights variable. And you can print this now. Print of female datas. I'm sorry, female heights, and here female heights. I'm using datas. So if you see here, these are the female values that are pulled out. So you applied the where condition, and the where condition, post applying the where condition here. So what is there in the female datas? All the indexings, 2, 4, 6, 8 and so on. And that particular indexing value, the field value, height field value, are fetched and stored in this female heights variable. So these are the values. In this value, what you are trying to find, the minimum height. What is the minimum height here? The minimum height is 1.56, correct? So the female, from the female data, what you are analyzing is, from the female student's height, the minimum height in the set of female students' height is 1.56. The same you can do it for maximum values. So how to find the maximum of it? You can say max. 1.78 is the maximum, okay? Or you can find out the mean. So the mean is 1.64. So it's like an average, okay? A mean. So minimum, maximum, mean are all functions which are there available on the NumPy array object, which you can apply. The same now you can try out for male. So change this condition from F to M. Now what you will see is all male, minimum value, maximum value and the mean value. Now instead of using this where condition, now you actually have to create a separate variable like this, male datas. Okay, male datas, and give M, and you can go for another variable like this and say male datas. So you can find out the male heights, minimum, maximum and so on. That is also feasible. So this is a little trivial because we are accessing through indexing. These are accessed through indexing. But the same is more simplified. This is the last demo that I'm going to show. Please bear with me for another 2 to 3 minutes. The better way or the easier way here is, in order to reduce your lines of code, what we can do is we can just create a conditional flow, okay, by using a Boolean expressions. So I can, instead of using this where condition, you can use the greater than symbols or the lesser than symbols or the equal to symbol just by using the direct student array itself. So let's say, for example, I'm saying student array of gender, okay, equals p of f. Now what happens here is, while we are using such standards of conditions, we can say fm data, okay. Now if I try to print this fm data, you will get true or false values. Where condition is targeting on indexing. If you apply the condition without a where, function, I'm sorry, without a where function, okay, if you apply the condition uh, straight template like this fm data is going to carry the true or false values. So wherever f is matched will become true. Wherever f is not matched, it becomes false. Now what is the advantage of this? The advantage of this is pretty simple. I don't need to have this female heights and male heights segregations like this. I can straightforward go ahead and say, okay, let me copy this. Let me comment out all these. Just another 1 more minute to complete it. So now what happens is, if I give a straightforward condition like this, you saw the difference. If it's with a where, it's index, it's capturing the index. If it's without a where condition, it is going to capture all the positions as true or false. Matched positions will be true, unmatched positions will be false. Okay. Now I can just use heights, no female or male. I don't need this condition at all. Okay. And I can use fm data here. Fm data and use heights everywhere, just heights, fm heights. It means fm heights, that is the meaning. Okay, so you get the respective value, the same value, there's no difference. If you notice here, there's no difference, it's all the same output. But suddenly I want the male. If I want the male, you need not change here, because this condition, let it be the same. If it's m, it's fine, it will be male, but you need not change here. Let the condition be the same. But what I can do is I can use a tilde symbol here. This tilde symbol says it's for not female. The condition, because it's all Boolean, right? All these Boolean values, not Boolean value represents what? Not Boolean means not true becomes false and not false becomes true. Simple, you are reversing it. So in that case, it's easier for us to capture the male data. If I remove this not and if you execute it, okay, you get the female minimum, maximum, and the average. If I use the tilde sign here, it's male data. In a matter of just by applying the tilde sign, you are reversing the condition. The entire condition got reversed. That's the advantage of using a straightforward condition like this without using a where. You can use where function, or you can use without a where function also. Where function will extract all the indexing. Without a where function, it will extract the values and apply the matched values to be true and the unmatched value to be false. So which version is useful for you? It depends on the use case that you're going to use. Now see how easy it is that we are manipulating on the real-time data, finding a minimum, finding a maximum, we are trying to figure out. Now this can be taken up to the next level, carrying the student height and the student age, and you can define an x and y values and see the graph of how many, what is the maximum height for the specific age category. So the students who are in the age between 10 to 15, On an average, the height of the female is this. So you can create a lot of questions and try to answer them by defining these kind of functionalities using the NumPy and integrating with the matplotlib. That's very important because there where we can generate the chart as well. You're getting it? Is this clear? If you have any questions on this, please let me know. This is the real-time use case I'm explaining you. What I've shown you as a demo right now is a real-time use case where we can apply the NumPy, because the ultimate goal is, even though we learn individual functions and the individual features of the NumPy, but we have to learn where we will apply this actually. How are we going to apply this tool or the library exclusively when it comes to the real-time data analysis? That's something very important. So that's why I took certain time. We can do more complex interventions into this where I don't find time. Probably in the next sessions, we'll catch up the remaining topic over here and then we'll move on with the next syllabus of sessions as well. I'll stop here. If you have any questions, please let me know.